chav, or just scan that QR code. Make sure you answer the question, guys. Make an honest attempt. All right, guys, about one more minute, guys. Only 6 of you have answered. Go to the URL and put pollev.com/chop. Got it? All right, guys, I'm going to pick it up. All right, it looks like everyone participated. Let's see what you guys responded. And it looks like an overwhelming of you got it. Looks like it could be correct. I don't remember. So let me deactivate and let's go over the question. All right. So this is implicit differentiation. I'm going to take the derivative. All right, guys, focus, focus, focus. The derivative of sine with respect to x is I'm going to write cosine xy, and then you're not done. Then you got to take the derivative of the inside. So we have to use product rule. I guess you can also call it chain as well. First times derivative of the second, dy dx, plus second derivative of the first, which is x, and all that equals 1. Cool or not cool? And then that's it. Everything else turns to algebra. I'm going to distribute. Bam, bam. So you're going to have x dy dx cosine xy plus y cosine xy equals 1. We're still okay? I don't see any issues. I'm going to move whatever does not have a dy dx to the right. So I'm going to have x dy dx cosine xy equals 1 minus y cosine xy. And then I'm just going to divide by x cosine xy. So dy dx equals 1 minus y cosine xy over x cosine xy. And then I choose that, and it looks like it is letter D. So way to go, guys. Okay, here we go. I do need your A game. Don't worry. We're not going to go right into these questions. I put these questions in here because I want you to see this is the hardest from all the topics in AB. This tends to be the hardest topic in calculus. Look at the percentage of kids that are getting question 26 correct. 25%. Look at question 28. 14% of the total population got those questions right. So supposedly this is the hardest question. This is my opinion. Yeah, that's okay. It's fine because it's just an opinion. So I was going to delete this opinion from YouTube, but I want to be real, so I'm going to leave it. My opinion is that I think teachers are not teaching this because they're just saying it's only going to be 2 or 3 questions on the AP exam. They'll get the 5 regardless of those 2 or 3 questions. I want to give you the best education there is, guys, so I want to teach it to you. Will you be fine if you do not understand this? Yes, you'll be fine. You'll still get your 5 if you want a 5. But I really want you to get it. So notice, I put a lot of thought into this, guys. I took your advice. I'm going to talk about algebra first before I talk about inverse functions. Cool or not cool? All right. So do you remember from your algebra days, and it's okay if you say no, what an inverse function is and the line that it reflects across? No? Okay. So draw a line through the origin on the grid. That line is y equals x. All inverses, if it does have an inverse, reflects across that line. So let me give you an example. Something like maybe an exponential function. And what's an inverse to an exponential? A logarithmic function. I tried to make it look more or less the same. It looks, I guess, kind of. I don't see the symmetry. Bless you. Okay. More or less. Not perfect, but that's fine. So this point right here, if I call that 0, 1, the inverse point is going to be 1, 0. So what do you remember? I'm going to call it original, and I'm going to call it inverse. Usually, we call the original f of x. We call the inverse f to the negative 1 of x. That's how you dictate inverse function. You have a coordinate point, a comma b. When you find the inverse of that same coordinate point, b comma a. Because your x and y switch, because of y equals x. If you have a slope, the slope of the original is change in y over change in x. And then referencing the original, the slope of the inverse is change in x over change in y. And let me put here referencing original so you won't reference. If you reference the inverse, it's always going to be change in y over change in x, right? Referencing original. Slope is always change in y over change in x, but referencing the original, change in x over change in y. Okay. Chop, I don't understand what you mean. And it's okay. Chop, I don't understand what you mean by this. Okay, let's do a sample so you can see what I'm talking about. What's your favorite slope? Give me your favorite slope. 3 over 2? I heard someone say 3 over 2. 3 over 2x plus, I don't know, 5. So let's say this is original. I'm going to call that f of x. And it's up to you whether you want to write or just listen, because you don't have to write this down because it's not calculus, it's just algebra. So just listen so you can take it in, guys. If I told you to find the inverse of this line, you would go, oh, okay, I'm going to find the inverse of that line. X equals 3 over 2y plus 5. I'm going to solve for y. So I'm going to move the 5 to the left, but I'll just, x minus 5 equals 3 over 2y. And then to get rid of the 3 over 2 in front of the y, you're going to multiply by the reciprocal. 2 over 3. Whatever you do to one side, you do to the other. 2 over 3. And then here's what I get. I have y equals, let's see, 2 over 3x minus 10 over 3. And here's how I show that this is my inverse function. All I want you to notice or recognize is look at the slope of my original and look at your slope of your inverse. All that happened was I took the reciprocal. That is it. Yay or nay? Okay, yeah, I know. This can be very tough, guys. So if I have a point here, and I call that point A comma B, then the inverse of that point, and it should be equidistant, but I didn't do it perfect, is B comma A. Cool. Now here comes the beautiful part. I'm gonna try so hard to see if I can explain it clearly. If I have a tangent line right here, the slope of that tangent is just f prime of A. Let's say I call this graph G, and G of x is equal to the inverse of f. And I'm gonna slow down. Have I done anything crazy yet? Okay. If you know the slope of the original at A, then you know the slope of the inverse, but not at A, at B. Because that B is an x value of the inverse, but it was a y value of the original. So if I call this G, I know G prime at B. And it is what? I'm going to call this, okay, I'm going to slow down because this is the breakthrough here. I'm going to call the slope C, some number. If you know the slope of your original is C, what is the slope of my inverse at B? Yeah, I heard someone say it. 1 over C. How'd you do it so fast? How'd you do it so fast? Tell me. The reciprocal. Check it out, guys. The reciprocal. That's what we were just talking about. So that's the beauty of it. That's it. That's the whole conundrum. So when we talk about calculus derivatives of inverses, guys, sometimes the inverse function is so hard to get because we're talking about, or sometimes the inverse function it might not even be possible to get. It might not even be a function. So that's why sometimes we work with the original to find the derivative of your inverse at a certain value. All we're looking for are slopes. You all right, Ortiz? All right. How do we feel? Do we feel okay? All right, so let's see what this says. So calculus involved, think about it. What if we want the derivative of an inverse function at a specific point, but we only have the original function and it would take too much algebraic manipulation to find the inverse function? Okay, sorry, I know I read that really fast. All I'm saying is, what if I want my slope, my derivative of my inverse? So look, let's use this right here. Look what it was. If I know, I'm going to write it right here. If I know f prime of a equals c, and I know the point a comma b is on original, so we know f of a equals b, and we know, and I'm going to use the top, that g of x is equal to the inverse of f, then we know g prime of b. How, Chav? Remember, f of a equals b. So that means g of b equals a. That's what it means, right? I'll slow down. You know what? Maybe I think for you guys, it helps to do a table. F of x, g of x. Okay. What do I know? I know f of x is the original. I know that g of x is the inverse of f. Yes or no? I know if I have a point AB, I know that that point on g of x is BA. So that means this, f of a equals b. So that means g of b equals a. I'm just flipping the points, x and y, they're inverses of each other. If I know f prime of a equals c, then I know g prime of b equals 1 over f prime of a, the reciprocal of whatever that is. That's what you told me a little while ago, 1 over c. Yeah, I think the best way to do it is with tables. I think tables is going to get us through this. This is why this is so hard. This is why this question is so hard, guys. Here's a visual. If you turn the page, here's a visual of what we just did. They should have just put it on the same image. This image here is the inverse of what you have on the left-hand side. Yeah, next time I'll see if I can do it. Let's see if we can work on this question together, and then we're going to work on the hardest question right now, question 28. It's going to be so awesome. I can't wait to see the percentages. All right, you guys ready? Oh, up. What? Oh, sorry. Oh. All right, check it out, guys. I'm going to go slow. Does it help if I call it g instead of f of negative 1? Okay, so then let's do that. Suppose f has an inverse, and I'm going to call this, let's see, f has an inverse, and I'm going to go g of x is equal to f of negative 1 of x. So then this, what is, I'm going to change it, scratch it out. What is g prime of 2? So I'm going to make a table. So what am I going to do? I'm going to go f of x, and I'm going to go g of x, which is the inverse of f. Cool or not cool? All right, let's see what we know. I know f of negative 7 equals 2. So then that means I know what for the inverse? G of 2 equals, heck yeah, guys, brilliant. All right, what else did they tell me? I know that f prime of negative 7 equals 4/5. So then tell me what I know about g. G prime of, is it g prime of negative 7 or g prime of 2? G prime of 2. That's the trick. G prime of 2 equals 5/4. All right, what do they want? Suppose that f has an inverse. What is g prime of 2? Question mark. All right, what's the answer? C. Look at that. You guys are all stars right off the bat. Okay, let's see. Let's see how we do. I'm actually looking forward to this. Go back to page 1. We're going to do question 28. And look, that's supposedly the hardest period. And guys, I want to make sure to give you a disclaimer. Guys, this is only your first day. Do not be discouraged if you get it wrong. These guys had the whole year and only 4. Look, even the 5s are having issues. Only 38% of the 5s got it right. So I'm going to start a poll. Try to do it on your own without looking at your friend. Let me go ahead and click here, calculus notes. And let it be differentiable. Boom. All right, try this one, guys. Number 28. Make a table. You can use the same QR code to answer. Not the Arc 10 one, guys. Number 28. Not 25th, 28. Make a table to help you out. You got it? And let's give it one more minute, guys. Thirty seconds. Did you answer it? No. Answer it, miss. Download the app so we can troubleshoot it later on today. I'm gonna figure it out, Miss Rowe, how to use the app. So I'll either download the app or I'll get someone to download it and see if we can troubleshoot it because I think it's more convenient to just open up an app and do. All right, guys, I'm going to pick it up. So if you haven't answered, please answer something because it is your participation grade. If you are having technical issues, send me an email. So whenever you see the word participation, if it's not 100, it's because of that. And I'll just reference the email. All right, I'm picking it up, guys. 3, 2, 1. Deactivate. And let's see how we did. Are we all over the place? So a lot of you said A, some of you said B, some of you said C and D. I don't know what the answer is because I haven't done it. So let's see. Let's see what the right answer is. So what I would have done, I'm going to make a table. So it says, let f be differentiable function such that f of 3. So here it is. So I already know that it's asking, look, g is the inverse of f. So I'm going to write f of x, and I'm going to write g of x, which equals the inverse of f. So here's my table. F of 3 equals 15. So that means I know that g of 15 equals 3. Yay or nay? I know f of 6 equals 3. So I know g of 3 equals 6. Are we okay so far? All right. And then they tell me f prime of 3 equals negative 8. So if I know f prime of 3, then that means I know g prime of what? Yeah, yes. Sorry, guys. Yeah, sorry. F of 6 equals 3, so that was a 3. No, not 6, 15. I heard someone say, that's okay. 15. So let me talk about this. Why? Because maybe we don't know that. Guys, we know f of 3 equals 15, so we know g of 15 equals 3, right? So if you know f prime of 3, that's f of 3, then you know g prime of 15. These two are related. These right here. These two right here are related. So then that means these two are related as well. Does that make sense? That's the point of tangency, guys. 315 is my point of tangency. So that means on the inverse, that's 15 comma 3. So I know g prime of 15, right? So if f prime of 3 is negative 8, then g prime of 15 is negative 1/8. I don't know if they're asking for that or not. Let's go to the next one. F prime of 6. If I know f prime of 6, which is negative 2, then that means I know g prime of 3, which is negative half. All right, let's see what they want. What is the value of g prime of 3? Oh, well, there it is. They want g prime of 3. So, man, look at that. So what percentage is that? 57%. You blew it out of the park, guys. Look, 14% compared to 57%, and we're just doing it for one day. And if you got it wrong, relax. This is really tough. Cool or not cool? Cool. Look, we just did the hardest question possible. Is this making sense? Do you guys like the table? Yeah, before we'd just go at it. And so I'm glad that we organized our thoughts with a table there. All right, then I think we're good now. So let's see if we can figure this one out. Go back to question number, quiz 15. All right, relax. I know you guys don't like inverse like that, f to the negative 1. So pretend this is like saying g of x is equal to f negative 1 of x. So then this is like saying g prime of 20. That's like what it's saying, assuming that g is inverse of f. So notice, look what they give you. F of 4 equals 20. So then that means I know g of 20 equals 4. This is how they're related. Oh, okay, g prime of 20. I'm going to take this f of x, I'm going to find the derivative, and I'm going to plug in the number 4. So I'm going to write f prime of x equals, what's the derivative of 2x? 2. And then remember that 6 squared of x is the same thing as 6x to the half. So plus, what's half of 6? 3. I subtract 1, so negative half. I'm going to go f prime of x. I'm just making it pretty now. 2 plus 3 over square root of x. I'm going to plug in a 4. 2 plus 3 over square root of 4. 2 plus 3 halves. That 2 I'm going to turn into 4 over 2. That's what 2 is. 4 divided by 2 is 2. And 4 plus 3, 4, 5, 6, 7. 7 halves. Okay, so here we go. If you know that f prime of 4 is 7 halves, do you know what g prime of 20 is? What is it? 2/7. Just take the reciprocal. Just take the reciprocal. Does that make sense, guys? Okay. All right. That's about as hard as it gets. Now we're going to go back to easier stuff. We're going to do the proof. Relax. Relax, guys. Relax. We're going to do the proof. We do not know how to take the derivative of inverse sine, but we do know if y equals arc sine of x, then we know that, let's see, what do we know? Sine y equals x, just from like basic algebra or pre-calc, right? I don't want to move forward until we are okay with this step here. Okay, I'll start again. Remember, guys, so I don't know how to take this derivative. We don't, right? We don't know. But what derivative do we know? So let's rewrite this. I want to get x by itself. Right now it says y equals arc sine of x. How do I get x by itself? By doing sine. Sine y will give you x. Because they're inverses of each other, right? Inverse sine and sine. Like, all right, side notes. If you had 5x equals, I don't know, 3. Don't write this down, just listen. And with numbers, you can inverses and reciprocals are the same with numbers. But if I told you that you cannot divide, how do I get rid of that 5? You would go 5 to the negative 1, and whatever you do to one side, do to the other, and those would cancel, and you would go x equals 5 to the negative 1 times 3. That's all I'm doing. See? So how do I get x by itself? I'm doing the inverse of your inverse, which is sine. So sine y equals x. Does that make sense? Okay. Maybe this is a bad example that I showed there. Okay. I don't want to continue until we are good. Are we good with this statement here? Okay. That's the only way that I can get rid of the arc sine, right? Okay. All right. Check it out. This, I can take a derivative. Chav, I'm so lost. I don't know what's going on. Okay, relax. I would like for you to not be a robot, but if you just know the derivative, that's good enough. Even if you don't know the derivative, you're still fine. I can take a derivative of this with respect to x, right? What's the derivative of sine? Cosine. I got to keep the y. And then chain rule. I didn't take the derivative of that with respect to x. I didn't take the derivative with respect to y. I took it with respect to x. So what did I put right next to it? dy dx equals, what's the derivative of x? 1. I'm trying to solve for dy dx, so I'm going to divide. So dy dx equals 1 over cosine y. Here's the problem. I do not want my derivative in terms of y. I want it in terms of x. So we're going to go back. I'm going to say side note. And the only thing that's going to help us here is the Valentine's formula. Do you guys remember the Valentine's formula? What is it? You guys sounded very excited. Yeah, heck yeah. Cosine squared plus sine squared equals 1. Keep the argument. I have a y, so I put y's on it. Are we okay? I want cosine y, not cosine squared, so I'm going to move the sine squared to the right. Chop, how is this helping me? You'll see right now. So I'm going to write cosine squared of y equals 1 minus sine squared of y. Are we still okay? Now I'm going to take a what? Yeah, square root. I heard someone say it. Good job. Cosine y equals square root of 1 minus sine squared y. Chop, I still don't see how this is going to help me. Okay, well, you're going to see it right now. I'm going to substitute. I'll wait for you guys to catch up. I can see you guys. See, look, I'm doing everything you guys told me, guys. I'm slowing down, chopped and screwed, and then I did algebra before we even started. Like, I listened to you guys. I put a lot of hours into this. All right, here we go. 1 over, and then instead of writing cosine y, I'm going to write square root of 1 minus sine squared y. Chop, you still have a y in there. You said you didn't want that. Okay. Tough crowd, tough crowd. dy dx equals 1 over, here's what I want you guys to see. 1 minus parentheses sine y squared. I want you to notice, look what I have right up here in that first line. What is sine y? Oh. There it is. That's your formula. Are you going to have to do this every time you take the derivative of arc sine, derive it from scratch? No, it is easier to just memorize it. Once you do it 3 or 4 times, you have it in there. Just doing it one time, you're not going to have it memorized. You have to do it like several times. What is chain rule? So let me go ahead and write it here. So d dx of arc sine of u equals 1 over square root 1 minus parenthesis u, close it, squared, du dx. There it is with chain rule. Cool or not cool? Yeah, textbooks do a bad job of putting parentheses. There it is. That's my argument of arc sine. So all we're doing is practicing using the formula. That's all we're doing. So what is my u? I'm going to write here that my u is x squared. So here we go. I'm just taking the derivative, guys. That's all I'm doing. So 1 over square root of 1 minus parenthesis x squared, close it, squared, times, this says du dx. So what's the derivative of u? 2x. Good. So my derivative, 2x over square root of 1 minus x to the 4th. There it is. That's the derivative of arc sine x squared. It's just using the formula. This one. Huh? Ask me, miss. U is x squared, right? So 1 over, wherever there's a u, I just type in x squared. And that says du dx, so I took the derivative of u, 2x. Because that's my argument in this one, see? That's what I have in there. That's your variable, u squared or x squared. Oh, because my formula has u and then I have it squared. U is x squared and x squared squared. Oh, that was a hard huh. First was huh, and then huh. All right. Here we go. You do not relax. You do not have to memorize all of them. I'm going to give you the ones that come out the most. You guys want to know the ones that come out the most? Okay. And I'm going to give you a hack on how to memorize them. The ones that come out the most, arc tan, circle number 21, and arc sine. Notice, look guys, here's the hack. Notice that the derivative of arc cosine is the same as the derivative of arc sine. The only difference is there's a 1 in front of it. Negative. Anything that starts with letter C, when you take a derivative, is going to be a negative. So look, arc tan, 1 over 1 plus x squared. Look at arc cotangent. Negative 1 over 1 plus x squared. I've never, well, I'm not going to say never because I don't know, because I haven't seen the test that you guys did. But the release tests that have been released, I have never seen an arc secant on the non-calculator side. If you have a calculator, just type in the calculator. You know, where's secant? Well, secant's just 1 over cosine. You can just go 1 over cosine, take the derivative, or arc. Well, we'll get there when we get there. I don't want to confuse you. Yeah. You probably will never have to worry about this one or that. These are the ones that come out the most. Sine and tangent. Arc sine and arc tangent. All right, guys. You can derive them all from proofs, but let's go ahead and write the chain rule for at least these 3. Actually, you don't even need that. Well, okay, I already said it. All right, here we go. Number 19, I'm going to go d dx, arc sine, and I know I already did it, but I'll do it again because, why not? So the derivative of arc sine of u is 1 over square root of 1 minus u squared times du dx. I'm just doing chain rule for all of them. Don't worry, guys. Now that we've done inverse trig, I'm going to give you a table of all the derivatives. That's what someone here in this table wanted, a table of all derivatives. We were talking about it recently. Remember? In the morning? No? Okay. Okay. ddx, arc cosine of u, negative 1 over square root of 1 minus u squared du dx. ddx of arc tan of u. Khan Academy has it as 1 over x squared plus 1. Guys, it's the same. 1 over 1 plus x squared and 1 over x squared plus 1 is the same. 1 over 1 plus parenthesis u close it squared du dx. There it is. Cool or not cool? This is just chain rule. You know what I mean? Okay. All right. We're going to do this one, and then we will be ready to tackle the one on the front page. Don't worry, we're almost done, guys. We're almost done. A particle moves along the x-axis, so its position at any time t greater than or equal to 0 is, and they tell you what the derivative is, or what the equation is. What is the velocity of the particle when t equals 16? How do I get velocity from position? Take a what? Derivative. Perfect. So I'm going to write x of t equals arctan of square root of t, and I'm going to put it on the side that square root of t is the same thing as t to the half. All right, here we go. V of t equals x prime of t, because I'm showing them that I'm taking a derivative. And the derivative of arctan, I have it right there. I can see it in the very top. It is what? 1. When I see the very top, I'm talking about right here. See? Formula. 1 over 1 plus, what's my u? Square root of t, close it. What do I put on the top? Squared. Am I done? No. Chain rule times 1/2 t to the perfect. Let's write it nice. Let's write it pretty. 1 over parenthesis 1 plus t, close it. Square root of t squared is t. And I see a 2, so I'm going to put the 2 right. Oh, I'll put it right here. 2, and then that t to the negative half comes down, square root of t. That's my v of t. We're almost done. V of 16 equals 1 over 1 plus 16 in parentheses, 2 times, what's the square root of 16? 4. So 1 over 17 times 8. Damn, what's 17 times 8? 20, 46. 136? Okay. Do it real quick. 17 times 8. Oh, 136?
Wait, was it right? Oh, it is 136.
Hey. Okay. You got it right. Good job. All right, guys. Let's go. Let's go. Okay, I'll stop. Let's go to the front page again. Yeah, I need to do a better job of sequencing. I just wanted you guys to see. All right. So when they took this AP exam, go back to page 1. 53% of the fives got it right, and only 25% of the total population got it right. This is question 26. See if you can do question 26 with no calculator. I will open up the poll in a little bit. Okay, the poll is on. So go to the front page and give it a shot. Yeah. Yeah, question 26, guys. Yeah, it's my fault. It's possible that I just confused you. Question 26. Give it a shot, give it a shot, give it a shot. And it's okay if you get it wrong, guys, but give it a shot. An honest attempt. All right, guys. All right, guys. Got it. You feel like you could come up and do it, or no? You got it, Ro? Would you like to come up and work it for us? Yeah, come on up. Ms. Rowe is going to go ahead and get started. Make sure you answer the poll, guys.
Next grade. Oh, okay.
All right, guys. Make sure you answer the poll because that's your participation grade. But here's Rowe going to work it out for us. All right, lead
I
us.
just wrote the equation first.
Okay.
Pause. Let me find it. Oh, okay. For like the derivative of tan x 1 plus whatever u is squared. And then I went back to the equation right here. And I rewrote it like so it looks like a normal to me for x. And then I plugged in x, which 4 over 1 times 1 over 4 equals 4 over 4, which equals 1. That's how I did that. So then I plugged this over here. 1 over 1 plus 1 squared, which is 1. So then I just put 1 over 1 plus 1. So 1 over 2. And then I just left it like that and then chose B.
Okay. Good job. Thank you. Yay.
He's like, so that's wrong?
No, I think you did it right. So she took the derivative, guys, using the derivative rules. 1 over 1 plus parenthesis, chain rule. 4x close it squared times
Oh my god.
4. So let's see. So 4 over 1 plus, and I'm plugging in x equals 1/4. 4 times 1/4 is 1. And then 1 squared is again 1 times, there it is. So then, yeah, you got it right. 4 over 2. So 2. Nope, sorry. A. Let me see. Where?
The chain rule.
Okay. Yeah, right here. You should have multiplied it by du dx. Yeah, make sure you write that, guys. Chain rule, chain rule, chain rule. So the correct answer is letter A. Let me see. I'm going to stop the poll. Deactivate. And let's see how we did. Split down the middle. But we still did better than the global average. But what happened? So now I know what the error is. If you got answer B, it's because you didn't do the chain rule. The correct answer is letter A. But I'm proud of you, miss. You did good. Cool or not cool? We learn from our mistakes, guys. There's a safe space. Correct answer is letter A, guys. All right. Let's see what we got. I'm not necessarily too concerned about how to take the derivative of arcsecant, but I think we should practice anyways. So look at your, so let's do the chain rule here. So look at d dx. So someone give me the derivative of arcsecant. 1 over u square root of, did they put plus minus u? Some books do have that. It depends, I guess. All right, some books I think put absolute value in front of that. All I'm gonna do is just use it, guys. I'm just gonna use it. I'm gonna go slow. You guys ready? U equals 5x to the 4th. So I'm gonna put that first so we can go slow. D dx of arcsecant of 5x to the 4th equals, and here it is, guys. I'm just going to go real slow. I'm just going to go and use my formula. 1 over, look what it says. It says u there, right? And what was my u? So that's what I'm going to put. 5x to the 4th, close it, square root, parenthesis, 5x to the 4th, close it, squared, minus 1, times, am I done? Times du dx, what's the derivative of 5x to the 4th? Done. Now all you're doing is just algebra. 20x cubed, don't worry, we're going to simplify it. 5x to the 4th, square root, let's write it. 25x to the 8th minus 1. Catch up to here. How many times does 5 go into 20? So that 20 turns to a 4. And then law of exponents, I have x cubed in the top and x to the 4th in the bottom. Bam, all three of those. I just have 1x in the bottom now. So my final answer, 4 over x square root of 25x to the 8th minus 1. You can actually do something about the 25x to the 8th, but we're going to worry about that another time. Well, maybe that's a perfect day to do it on Friday. We'll do algebra. All right. Are we ready for this? Yeah, I think we are. Remember that cotangent x, guys, is cosine x over sine x. I don't know if we remember the restriction equation for cotangent. See, I'm wondering if we should even talk about it. Yeah, unit circle's coming back. It does not go away. Where is cosine? Where is cosine? Where is cotangent? -1. Because that's what this means. Look, it says when x is -1, find the equation of line cotangent. Okay, so y equals arc cotangent of -1. So this right here means cotangent of what angle is -1 from pre-cal. And look at the one in quadrant 2. What radian is this? Yeah, 3 pi over 4. Cool. All right, so I have a point. Chop, what are you doing? It says find the equation of a line tangent. So I need a point, 3 pi over 4, well, 1 comma 3 pi over 4. -1. -1 comma 3 pi over 4, because that's the output. It says y equals. Are we okay? All right, now I need slope, and I find the slope by taking a derivative. So y prime of cotangent is the same as tangent. The only difference is I have a what in the front? Negative. Negative 1 over 1 plus x squared. If you go to Khan Academy, you're going to be in the habit of 1 over x squared plus 1. Not a big deal. Cool? I'm just going to plug in negative 1. Y prime at negative 1 is, let's see, negative 1 over 1 plus negative 1 squared, so 1 half. Here's my tangent line. Y minus 3 pi over 4 equals 1 half, parenthesis, x plus 1. I'd leave it alone. Oh, with a negative? Yeah, negative 1. Minus a negative is turns positive, no? Oh, negative 1 half. Yes. Thank you. I would have gotten it wrong. I'm going to edit that in the video. No, I'm not. I'm real. I'll leave it. I make mistakes. All right. How do we feel? Do we feel okay, guys? You have a delta. It's really short. It's only 2 subtopics. I think 12 questions, I think. So a delta, and at the moment, we don't have a UH. There will be, but we don't have it yet. So just knock out the delta, guys, and we'll call it a day. Yeah. Check it out, guys. I want to show you guys something. Keep doing what you're doing, but I just want to show you guys the Desmos graph for that. Look, check it out. Check it out, guys. Y equals arc cotangent to the negative 1 x. So there's arc cotangent, right? And then give me the tangent line that we got. Y minus, what was the tangent line that we got? 3 pi over 4 equals negative 1 half x plus 1. Check it out. That's cool, right? You don't think that's cool? Yeah. All right, guys. Now we're done. Take care of the delta, and we'll call it a day.